Okay, so question number 3 asks us to modify the turtle walk program so that we have 2 turtles, each starting somewhere random and keeping both the turtles moving until one of them exits the screen. So this isn't super explicit, but they do want us to modify the original program, so not the random version that we made up here, the original 90-degree churn program from the chapter. So go back and copy it again if you have completely ruined it during your randomness section up here. And I already did that, and I re-commented it with all of our comments up here. So now we're back to where we are. So what we need to do is we need to make 2 turtles. Take some notes here. We need to make 2 turtles. Have a while loop that moves them while either has not exited. Okay, so that's what we need to do. So that's pretty simple additions. But I'm going to add an extra cleanup thing. I want to refactor, so change my code, rewrite my code, move my code around in such a way that refactor the turtle movement into its own function. Because now that I'm going to have 2 turtles moving around exactly the same way, much like I have a function that just checks whether a turtle is in the screen, I'm also going to make a function that moves a turtle in this specific way for me. So we're going to refactor this to this stuff right here where it determines churning and moves the turtle. I'm going to refactor that into its own function. So I'm just going to copy all that out of there, and I'm going to write a theoretical function here where it's going to move turtle and then call Julia. So there we go. So I'm going to go up and define that function. I'm going to define up here above main move turtle, and it's going to take an argument t for turtle. And this is going to move, it's going to turn the turtle t in either 90 degrees left or right and move forward 50 units. That's all this function's going to do, and it's going to do that by just copying the stuff that we wrote before, or the stuff that was provided for us, rather, for the random selection of turning left or right, and replacing the specific object names, in this case Julia, with a generic parameter name, which is, of course, t, in the case of this function that we are defining. So there, that function is defined. Now, it flips a coin, determines whether it's 0 or 1, turns left or right, and moves forward 50. So now we can call move turtle Julia down here, and it'll just move Julia. Similarly, we're going to want to create another turtle and have it move as well. So let's create another turtle. Let's create a turtle named Alex, our old friend Alex the turtle. And I'm just going to initialize Alex right up here next to Julia. And I'm going to go ahead and switch Julia and Alex's shape both to the turtle shape. So actually copy that and paste that down here, and go ahead and delete Julia, replace her with Alex. Okay, so now this is going to run at, if I click run now, and I will go ahead and do so. Whoops, I have an error on 31. I've made a typo somewhere. Where is it? Oh, all of this should be out a block. There we go. So I'll run it, and we have these 2 turtles, and they're going to do their thing, making random turns until Julia, which is, I guess, this turtle right here, leaves the screen. So, because currently we're only checking if Julia is in the screen. So we also need to check whether or not Alex has left the screen. So we're going to run isInScreen for Alex as well. So this Boolean here is checking, is Julia in the screen, or is Alex in the screen? Or basically, has Julia left the screen, or has Alex left the screen? So now if either of them leaves the screen, we should see this momentarily. Whether or not it's Julia or Alex, it doesn't matter. If either of them leaves the screen, come on, guys. Come on. If either of them leaves the screen, it should stop, but it didn't. Why is that the case? We've broken something. I've broken something somewhere. 1 second. Let me figure out what's wrong, and I'll cut back in when I figure out. Alright, so I figured out I used or instead of and, which was my bad. That was faulty logic on my part. Because it's going to keep running while, if I have it set to or here, it's going to keep running, and you guys might have already figured this out. But it's going to keep running while either of these things is true. So if either of them is true, it's going to keep running. So that's not what we want. We want it to keep running while both of the turtles are still on the screen. So is Julia on the screen? Yes. Is Alex in the screen? Yes. Okay, then keep running. But as soon as one of these is false, it should stop. So now let's wait to see how long it takes. So either one of these turtles leaving the screen now. Come on, guys. Come on. Oh my gosh. Come on. Okay, either turtle leaving the screen causes it to stop running. So, great. So we did this. We did this. We did this. So now we need to do the remaining part of the problem that I forgot to set up earlier, which is we need to have the turtle start at a random location. That's easy. If you have forgotten the appropriate methods for that, all we're going to do is just have Alex go to and Julia go to, and they'll go to some random location. Now, we know that the screen is defined by screen.windowWidth and screen.windowHeight. So that is determines how far away from 0 on each side of this is. So if we wanted to make it general so that it works with either of those, we need to have Alex go to somewhere between window width negative window width and positive window width, comma, negative window width, negative window height, positive window height. So screen.window, what is the actual window underscore width? So this will return the width of the screen from 0 to the right side, and screen window width. So we need to make this negative screen window width. Now, if we do this now, it's going to pick some number between, I think this is 200 is the window width, something like that. So it'll pick some number between 200 and negative 200. Or sorry, it'll pick the way this is written currently, right now, it's going to go to 200, negative 200, which will put him right down here. Which is not what we want. We want it to be randomized. So we need to change this into a call to rand range. Alright, and you can see that this is already getting kind of messy. So if we wanted to bump this out into its own variables, we would break it out into Alex X start. Whoops, that should be an equal sign. Alex X start. So Alex is going to have his X starting location set somewhere between the window width and the negative window width, and I'm going to actually inverse those just because. Great. And then I'm going to have Alex Y start be set to a similar version, but instead of window width, we're going to set it to window height. So let me do precisely that. There we go. So now it's picking a random spot on the screen somewhere between the left and right edges and somewhere between the top and bottom edges. And then I'm going to have Alex go to that location. And then I'm going to do the same thing for Julia. Now, if you're thinking to yourself, Ryan, you're copying and pasting code, shouldn't this random selection of a random place for them to start, shouldn't that be handled in a function of its own? And the answer is yes, probably. Especially if we wanted to make new turtles and have them start randomly as well, we would have to copy and paste this set of instructions every time and change all the variables for it every single time. So there is an opportunity here to refactor this into its own function, but for right now we'll leave it as is, even if it's not perfect perfect coding practices. Alright, so this is a cool error. So let's see where that is going on. So it's having an issue on line 4. I've messed this up horribly. Okay, let's figure out what's going on. I'll say line 45. Good, that's easier. Oh, it's because I have negative here. This should be, as you can see, I've messed up. I should be calling this like this to be able to actually get access to these variables. So I will fix this. I will cut out this section. Okay, so if you were following along, you probably got an error when you tried to run that. That is because I forgot to put in the parentheses after these parameters here of screen and window height. So I did that, and now what we get is they both got moved way outside the screen. Okay, so this is not good. Something's wrong here. Okay, so if you're following along, you got some funky behavior. That is because I forgot to add in these parentheses to the end of these calls to the value of window width and window height. And I also forgot to have it divide by 2, which means that it was it was having issues. But if we run it now, it should, yes, put us somewhere on the screen. Now, this is still having some issues here, and that's because, like I did before, I did not. This is a situation where if I had refactored this so that setting the random location of these turtles was in its own function, I wouldn't have to go through and have all those errors. So I should have done that to begin with. But now we have a version that is working and setting them somewhere random on the screen and then starting them from there. So that's good. The only problem is now that their tails are down before that. So let's go ahead and fix that. So we'll just have Alex be up and Julia be up, and then they'll go to their spots, and then we'll have Alex be down, and we'll have Julia be down. Very good. Awesome. So now let's run it one more time. So they start in a random place, start moving, and as soon as one of them leaves the screen, they stop. Very good. Awesome. So take a look at this. I'll scroll slowly. This end screen function is still the same. We refactored the movement into this function. Between now and the next video, I will probably refactor the random start location into its own function as well. So I will probably take care of that, and then we'll get it set up so that all of this is ready for that next video.